Hey everyone, my name is Scott, and today we're going to solve the range sum query immutable problem on LeetCode. This problem, at the face of it, is very simple, and the intuitive thing to do would be just to jump into writing a naive solution. However, if you do that, you will time out on large input for this problem. Let's look at the problem definition and think a little bit about why that is. And the problem definition is very simple. It says, given an integer array, find the sum of elements between indices I and j, I less or equal j, inclusive. Very simple problem. I know when I first read that, I said, why is this problem a dynamic programming problem? Which it is. It's a dynamic programming problem. The first thing you think is very simple. Well, I'll just write a loop. I'll start at index I, and I'll have a running sum, and I'll sum up to j, and I'll return that answer. Well, the problem with that approach is that the time complexity of that algorithm is big O of n. It's linear, which, linear time complexity for tons of algorithms is great. But in this situation, we will time out, and here's why. Look at these two notes down here. It says we can assume the array does not change. So what that tells us is we can remember previous answers, which is what dynamic programming is all about. It's about remembering things that we've computed before. And this is the big one. There are many calls to the sumRange function. What that tells you is that they are going to call this function over and over and over again on large input. And if you have that naive solution that we talked about, which is just looping from I to j and keeping a sum and returning that sum, you're going to time out because that's a linear operation and they're doing it over and over again. So what we need to do is we need to go from that linear time complexity, big O of n, to big O of 1. We need constant time complexity in order to pass these large test cases that they're going to throw at us. How are we going to do that? Well, this is a dynamic programming problem, even though on the face of it, it doesn't necessarily look like it is. It's kind of a disguised dynamic programming problem. And what dynamic programming is all about is remembering the answers of things that we've solved before. Okay? So here's the intuition behind what we're going to do. We're going to set up a memo, like we've always done in dynamic programming. It's going to remember solutions to things we've solved. And it's going to keep the sum up to each index of the array. So for 0, it'll have -2. For 1, it will also have -2. It's the sum up to 1. For 2, it will have 1. -2 plus 0 plus 3 is 1. For 0, 1, 2. For 3, it will have, this was 1 plus -5, it will have -4, so on and so forth. So our memo pad is going to keep the sum up to that index, of all the elements up to that index, okay? And then all we have to do to compute the sum in between indices I and j is go into our memo pad, get the sum up to j, and then subtract away the sum up to I minus 1. So let's say we're given I is 1, j is 3. Well, our memo would say that the sum of j, sum up to j, including all these elements, would be -4. And that the sum up to 0, which is 1 before I, is -2. So we just subtract that away, and we end up with the sum in between these two elements, which is -2. Okay? So that's what we're going to do. Let's implement it. Now it's set up as a class, so let's set up our class variables. We're going to keep our hash map of integer to integer. We're going to call this sums. It's usually called memo, but we'll just call it sums this time to represent what it is that we're actually storing in here. And we're going to keep the integer array of nums. For our solution, this actually isn't necessary, but if you're setting up a class that's going to keep sums of integers, you should probably keep the integer array around as well. So here's our constructor. So let's write the constructor, and the constructor is going to do the work. This.nums is nums. We just store the array we're given. So the initial sum is 0, and this is sort of important to handle an edge case for us. We're going to put into our sums value -1, 0. What this signifies is for index -1. In this case, let's say we're given a problem where I is 0. They want the beginning index to be 0. Well, then we would check what the sum up to -1 would be, because we want to subtract away the sum of all things before I. And in this case, if it's -1, we'll just return 0. So that covers that edge case for us. And here, in our constructor, we're going to loop through the nums array. We're going to add up our sum. Now remember, this sum is just keeping the sum up to this point. And then we're going to put that sum into our memo pad, which we're calling sums. And that's it for the constructor. So let's go over again really quick what this constructor is doing. We put into sums -1, 0, so if we ever check what the sum up to index -1 is, we know it's 0. And then we just keep a running sum of all the elements we've seen so far. And the memo pad contains the index into the array and the sum of all elements up to that index. That's all it is. Now you might say, well, this is a linear operation. This right here, the complexity of this function is big O of n, because we're looping all the way through the array. So this is big O of n. However, the problem states there are many calls to SUMRange function, which is down here. SUMRange function is going to be a constant time operation because of the work we did up here. Now, because of the work we did up here, implementing SUMRange is as easy as it gets. We just return sums get j. And remember, what is sums get j? Sums get j is the sum of all elements from index 0 up to and including index j in the array. And then we subtract away sums get I minus 1. Now remember what sums get I minus 1 is. It is the sum of all elements from index 0 up to index I minus 1 inclusive. So what do we end up with when we perform this function? The sum up to j with the sum up to I minus 1 subtracted away, which leaves us with just the sum between I and j inclusive. So let's run our code, see if we dotted all our I's and crossed all our T's. We did, which is always good news. And we have the right answer. Let's submit it and make sure that it actually goes through. And we got an accepted solution. Awesome. So to recap really quick, the key to this problem, and what makes this a dynamic programming problem, is that we're remembering these sums. We're remembering sums that we've computed before. In our SUMRange function, which is being called many times, we're told here this is going to be called many times, that we get our SUMRange function down to constant time complexity. So if you're ever faced with a problem that says we're going to call this function many times, you want to find some way to optimize the running time of that function. And we did that here in the constructor by setting up these sums. So what we had to do to get this sum between I and j, get the sum up to j, subtract away the sum to I minus 1. That is it for this problem. Hope you enjoyed it. We'll see you next time.